Hello, I'm Stephen Jenkins, hardware engineer here at Mission Communications, and today we're going to introduce you to the MyDro emergency backup pump control. So this video is going to cover some of the key features of this emergency backup pump control, or EBPC as we will refer it to. We will go through some features and specs, kind of discuss how it fits into your lift station, and then we'll go through some installation notes. So one thing you've got to ask yourself is, at your lift station, if your primary pump control fails, what happens next? How long will it take to get some of those replacement parts in? Typically that can take weeks, maybe even months, depending on the pump controller. Once those parts come in, you got to get an integrator, possibly reprogram the pump controller. How long will that take? Another thing is, do you already have a backup in place? If not, what are you going to do to prevent a spill? In the case of this pump controller going down, do you have anything that will notify you or your customer of a potential spill? Well, with the MyDro emergency backup pump control, we address all these issues. Not only that, but it all stays within your 123 SCADA portal. Now, adding it to the lift station, of course, is for emergency use only. You will still have your primary control until that goes down, and that's where we kick in. This gives you peace of mind against your primary pump controller suffering any sort of damage due to electrical weather events, circuit board corrosion, programming faults. EBPC provides backup for 1 or 2 pumps, and that is configurable. It addresses the worst case of long waits for your parts coming in to repair your primary pump controller. This can also run for weeks on end without any sort of interruption. And it runs seamlessly whether your unit is online or offline. For your EBPC, installation is very easy with a small amount of hardware needed to get your system up and running. So referencing our little demo back here, you're going to have 2 OP400 or our current switches. Those are going to tie to your pump starters, and those go into digital 1 and 2 on your MyDro. It's not required, but it is recommended to have 2 OP750s. One of these is going to tie into your normally open float and a normally closed float, and that will tie into the other SMP. These 2 floats, one is going to sit as far down as you can as the lowest point. That will kind of start or end the pump cycle, and then your high float will be above all your other floats as the emergency float. If that one tips, that's when your pump controller has failed. And of course, through your MyDro, all of this is only accessible if you have firmware version 18.3. Like other hardware from Mission, the EBPC lives seamlessly through your 123 SCADA portal. The EBPC uses existing 123 SCADA features like the lift station widget, while introducing new features like the remote force run command. You'll be able to see digital inputs through the digital table. You'll be able to see if 1 or 2 pumps are running. It uses the same alarm certifications and schedules you already have set up through your portal. The same reports are utilized for pump run, CSO, and SSO. The runtime reports will also show data regardless of whether the primary pump controller or the EBPC has been in use, and it switches seamlessly between the two. Alarm event reporting is the same, and all data and reports are stored and available through your 123 SCADA portal. So you've purchased your backup pump control system. What happens next? So whether the system has been installed or not, you can go ahead and call tech support. And what tech support will do on their end is enable that system on the back end, which will then give the option through 123 SCADA to send a command to your MyDro, which now makes this enabled for the emergency backup pump control. So a prerequisite is if you have a MyDro already out in the field, it will need firmware version 18.3. So if it's not on 18.3, tech support will send an over-the-air command to get it upgraded. And once that happens, the system can then take the command and the configuration parameters will now show up on your MyDro. So with your EBPC, now it comes time to install the equipment to help your MyDro handle the floats and the pumps. So again, as stated before, we're going to have 2 SMPs. One of the SMPs is going to be tied to a normally open low flow. where the other SMP is going to be tied to a high flow, which can be purchased through Mission. And these are daisy chained and they communicate to the MyDro via the RS-485 communication cable. You're going to have two OP400s, the current switches. Those are going to tie into digital 1 and digital 2 on your MyDro, and those just get zip tied to the power wires of your pump starters. Next is using an interposing relay. So on relay 1 and 2, you're going to tie into the pump call. This is where the pump is called to start. That's going to tie into where your primary pump controller is. So in case this guy goes down, the MyDro will take over once that high flow is tipped and then call through the pump call to start your pump. All this being said, again, you'll have a high flow, which is going to be above all the other floats. And you're going to have a low float that's going to sit just below your lowest floats. And this will be in a tip state. And the second that this guy tips is when the emergency backup pump control is kicked on. Right, now that we have everything wired, the next step is to actually configure your MyDro for the emergency backup pump control. So you will take your config key and you will key your unit. Of course, you have to be online to enter the config mode. You'll see your screen turn yellow. Now we're going to hit the config button. We're going to keep going until almost the very last screen. So you go past here, past your firmware, and you'll see backup pump control or backup pump setup. So here you will select the number of pumps, 1 or 2. Since our system has 2, we're going to have 2 on here. Now by default, your high flow will be set onto digital input 4 and the low flow on digital input 8. Now these are standard. If you want to change those, you have to call tech support and they will have to reconfigure the SMPs for different digital inputs. The minimum on time is once a pump starts, that is the length of time the pump will run before shutting off in case it's a premature start. Now with all of this wired up, what we have here is IO configured. This is basically the last step saying, is everything wired? Do you have your floats, your SMPs tied in, the relays, the digitals? If everything is set there, you're going to click yes. And at that point, your emergency backup pump control is now enabled and ready to run. If you hit the next screen here, we have a test screen. So hitting this test button will unlock the relays. So right now they are grayed out since we're in the pump controller. If you hit the test button, you get the same on-off option just to test that your pumps are working. Otherwise, it can also run through a cycle. And if you tip the floats, you can do the same thing with that. So again, once those are set up, if you've run through a test, that's the last screen. You can exit your config mode. And now your system is ready to go. And as a quick test, your low flow has to be in a tip position. So we have some low fluid in here. All I have to do is grab the high float. And for reference, you can go to the status screen. Keep hitting. Right here, you'll see pump 1 and pump 2. We've got AC power to the system, which is good. So the low flow is in a normal state, so it is tipped. The high flow is in a normal state, so it's hanging down here, so it is closed right now, where the normally open flow is also closed. So just to test the system, we will take our high flow, we will tip it. You will see that it went into an off normal state. Pump 1 was called, and then we detected current on the pump wires, the pump starter. I have the pump running. And in about 30 seconds later, you'll see pump 2 do the same thing. The first circle is going to call the pump to start, and it's going to be confirmed by the current switch shortly after. Here's pump 2. It's called to start. It's running. We've detected current on the wires. We're good to go. And we can put our high flow back down. With this, it's going to run until that low flow goes into a normal state. So all we have to do is pull the float up. We'll see the low flow changed. Turn off pump 1. And again, here we will see the pump turn off 10 seconds later. And that was one quick run of the emergency backup pump control. So here we have my 123 SCADA portal. And one of the great features, of course, is you can have saved desktops. So I will open up my desktop for the emergency backup pump control. And here you will see your typical windows. So I've got Supergraph here. That'll show me all my signal, AC power battery, along with the pump 1 and 2 and other information. I got my RTU view, which this will look a little different as we only have pump 1 and pump 2 shown, and of course your high flow and your low flow, along with the other information from the unit. You will see the relays, which I can't select these. I can still select 3, but relay 1 and 2 are tied into the system, so I can't do anything. I've got the pumps shown here. They're blown out, which again I can just drag and drop if needed. Part of the desktop, I can build it how I want. I've got my digital table here. This will show me the digital inputs as they changed. So right now we are in a normal state where digital input 4 and 8 are both showing in their closed state. We got the widget right here, which right now we've got both pumps stopped. We have 0 faults, nothing is running. This time right here is the time since the last event. So about 30 seconds ago, one of the pumps turned off. So we have been in a holding pattern. So just a quick reference now. I will test the high flow. What you see here in a second is the little widget has started running. You can see the same thing here. This little bar graph right there start moving. We see digital input 1 detect the current. And then relay 1 called itself to start the pump. I tipped it a couple times, so that's why we have some extra information in here. Obviously, we see pump 2, relay 2 kick on. And we'll see digital input 2 record the current from the pump. So that's looking good. And then that's going to run until digital input 8 goes into an off normal condition. At that point, it has run through a cycle, which we're speeding this up. Then you'll see the pumps turn off, digital inputs go out as the AC current detectors no longer detect current. Everything goes back to normal with your inputs 4 and 8. So one of the cool new features is force run command. So whether you have a storm event coming, you have maintenance, you're at a remote location, you need to pump down that lift station, you can go to your commands, operations, you're going to find forced run, backup pump control forced run. All you have to do is hit that. Again, you'll see relay 1 call for pump 1. We see it spinning. AC detection has recorded the current. And what it's going to do, and you'll see pump 2 turn on here in a second, is no matter where that high float is, it's going to turn on both pumps to essentially pump down your lift station until the low flow goes to an off normal condition. At that point, your lift station is empty. So if you're on the road, you know a storm's coming, you can hit this command, pump down your station, and get it prepared for when an event is coming. Great feature. That is the force run command for the emergency backup pump control. And on Supergraph, what you'll see here is these little lines right here indicate when a pump has been running. So we've been playing with it a little bit. You'll have your pump 1 and pump 2, and it shows you the length of time that that pump has run.